I wanted to find out if we could develop a video game from scratch using OpenAI Codex to do all the development. I've never built or deployed a game on Steam, but with the new Codex development tool, I thought we might have a shot at doing something really simple. And I wanted to see if we could develop a game where the main gameplay element is interacting with an AI, so we could combine a bunch of different AI elements here. So I came up with a number of very simple game ideas that were essentially entirely text-based, where the user would interact with an AI that would come up with a bunch of different personalities. My first thought was the idea of a suicide hotline where every AI is a different personality of someone who is having a tough time and wants to kill himself, and the user has to talk these people down off the ledge or not, depending on how he wants to play the game. And you get points for rescuing people and convincing them that they don't want to kill themselves. And I thought, that might be a bit intense / dark to begin with. And also, I wasn't sure if we would have issues with OpenAI and other LLMs guide rails on self-harm and stuff like that. We might not get successful API calls discussing such issues. So what I settled on instead was building a simple game where the user is working at an office and telemarketers keep calling him. And the goal is to keep these telemarketers on the line with you for as long as possible before they realize that you're not serious about buying their product. And the idea would be every telemarketer calls with a different product and a different personality, sort of realistic backstory. You have a conversation with them, and the AI, on top of this AI, we have another AI agent, an adjudicator that looks at the conversation at each stage when the user says something and tries to decide, is this a serious conversation or is the user, the game player, just jerking around the AI, at which point it hangs up and that's it. And your score is however many words the AI used in the course of that conversation. I thought at least this would be the basis of a super simple game. We could make more complex stuff after that. So my first thought was a game like this where we're interacting with a live AI is going to require API calls, and that means access to an LLM through an API key. Obviously, I'm not going to build a game that contains, for example, my personal API key. I wanted to figure out what best approaches we could take in order to do this safely. And so before starting to use Codex at all, I went to ChatGPT using their deep research tool and asked it to produce a best practices guide for me about how to interact, or how to build games that had to interact with APIs. And what it ended up suggesting, which is incidentally not what I ended up thinking is going to be a good approach. It was my initial build, and so we're going to look at what happened as a result. But what it ended up suggesting was use a proxy server that you control, and people playing the game hit the proxy server, and your proxy server has the API keys and hits the LLM. I was willing to try this from an experimental point of view. Obviously, I was concerned about the latency that this was going to introduce, and that turns out to be a valid concern. So ultimately, I don't think that's going to be a good direction. But we can look at what happened just for the sake of argument. So beginning to build the game, I first tell Codex that I want it to look at the best practices guide that I've put together. And once it's looked at that, I give it a description of the game that I want it to build. And this includes the basic concepts as well as basic platform guided. So I say that I want it to be deployable on all these various operating systems, so you can come up with an architecture that will work for that. It's going to be released on Steam, and here's the basic concept of the game, and go and build it. My first attempt is using Codex with O3 Mini, which I thought would be a cheaper approach to using the full O3. And it would in theory, except it doesn't work very well. And I've seen this before with Codex. Some models work better than others, and it's not always the ones you would expect. I've used it with 4.0, which is a general purpose model and still seems to work pretty well. Whereas O3 Mini, which is in theory a reasoning specific model for coding, doesn't interact with Codex that well. Why? Don't know, but that just happens to be the case. So I had to use the full O3 for this project instead, or at least I did in this first version of it, and that was expensive. So what follows in the next couple of hours, which includes a lot of dithering about a particular code base, which it doesn't interact with that well still, cost me probably about $50 because there is a huge amount of context that it needs in order to go through this every time it looks at something and makes a change. So this is not particularly cheap way to develop, and I'm going to be experimenting with other models as the process continues. In any event, in rebooting this after my first O3 mini attempt, I add a couple of lines of instruction to the end of my prompt, including that I want it to keep a running log of everything it does while it's working on this build. And every time it does something, update the log with the goal that any LLM reading it should be able to understand what's going on in the project and pick it up from where it left off. This is something I've found to be generally useful when using Codex to work on complex projects because you only have a limited amount of context window in Codex, and the more you get into it, in fact, the worse it works, even before sometimes the entire context is used up. And in addition to which, Codex can just crash or whatever. You may have to restart, and you don't want to have to teach the model everything it needs to know about the project from scratch. So it's great to have this running log that the model itself, that Codex, will update after each step. And that way you can resume the project, relaunch Codex at any point, or with a different model even, and just pick up where you left off. So I give it these instructions, I explain how I want the game to work, and I give it a very rough guidance on feel. I say I want it to be sort of 90s pixel art style to keep it super simple. And I also include some notes on community. I say it would be nice if there were a leaderboard available to all players of the game so we could see how other players are scoring. Still pretty minimal guidance. And what it comes up with is an architecture using Godot. Now, if I were a game developer, I would know about this, but I'm not, so I didn't. Apparently, Godot is a simple game engine that makes it easy to deploy code to all popular platforms. So I should, in theory, with a single click, be able to deploy this to Windows, Mac, and Linux altogether, which is great. So I have it start developing, and immediately it runs into problems, a lot of which have to do with the fact that Godot has its own conventions, its own programming language, which is somewhat Pythonic, but not quite. And anytime you interact with one of these specialized coding languages or specialized SDKs, GPT will just do a worse job of interacting with it, probably simply because there's less examples that it has to draw on. And so it actually took quite a while to just get a very, very basic text interface up and running. And mostly because it was making simple errors having to do with Godot's coding language, not getting indentations right, not initializing variables correctly. And of course, this is stuff that would still have taken me longer if I were coding it myself. But it was frustrating to see the extent to which Codex, even using its most sophisticated reasoning model, could not remember basic elements of coding in a language that it should really still be familiar with and was kind of familiar with, but not very. I mean, it needed a lot of hand-holding, and it needed a lot of reminding of what to do. And as a result, we fannied about quite a lot because every time I was having it make changes in the code that enhanced in theory, the gameplay. I don't know if we ever got to the state of even calling it gameplay, but every time we were making changes to the code that sort of moved the game forward, it would usually introduce some regressions or bugs in formatting that then separately had to be fixed. So there was a huge amount of going back and forth over that. Now, I specified using DeepSeek R1 as the LLM in this game entirely because I thought it would be cheaper, because, of course, DeepSeek is very cheap. And my approach at the time was, again, using a proxy server with its own API key to hit up DeepSeek for all the players of this game, all the millions that it will eventually have, and then send the responses via the proxy server back to the user playing the game. Now, this turns out to be a terrible approach for a few reasons. One having to do with LLM, the other one having to do with the proxy, which I already touched on. The latency that came out of this system was absolutely appalling. and I can spend more time debugging it. But the fact is that a game like this, where you're interacting with someone as sort of a chat window, text conversation based, has to have low latency, and I just don't think the proxy server is going to work out. So I have another idea for a new implementation, which I will cover in the next iteration of our progress on this game. But the other problem is that DeepSeek really, really sucks. It's awful. I mean, I know that people have published stats saying that it's a very capable model on the level of whatever latest reasoning. That's garbage. It's an awful, awful model. Its performance, at least in terms of generating text responses and so forth, and this is not to do with speed. It's really the quality of the responses is on par with, at best, ChatGPT 3.5, and a lot of the time it feels just like 3. And based on the way it seems to have been trained, that's not terribly surprising. But if you're expecting any sort of sophistication in character understanding, for example, which I kind of was here, it's going to be a total disappointment. And so the DeepSeek characters that it came up with, I was asking it to come up with a telemarketer character and something that he was telemarketing, and they were all like the most trite, semi-comic or fully comic, but not really funny, just like comic characters that you could possibly imagine, and they were all extremely similar. So I don't think that the game will work in a DeepSeek environment, because DeepSeek is going to come up with the same maximally prepackaged, uninteresting, and not sophisticated character that it possibly can, and then it can't really carry on a good conversation afterwards. From my previous experience with DeepSeek, this isn't a surprise. When DeepSeek originally came out, the first thing I did was a series of sort of jailbreaking experiments to see if I could get it to tell me things it wasn't supposed to, and it was pretty easy. DeepSeek clearly is not very sophisticated, and it's cheap because it's cheap. So this means that to get this game to actually work properly, I'm going to have to dispense with the proxy server and with DeepSeek and come up with a new approach from scratch. And that means also getting rid of the instructions on API key best practices, which I had Codex consume to look at this because they're no longer relevant. So here's what I have in mind for the next version of this game. Rather than use the proxy server, I'm going to ask users who download the game to put in an API key to an LLM so that we can get rid of the latency issue and we can use more sophisticated LLMs, basically whatever the user wants, in order to create a faster and more realistic interaction. Will this work? Also don't know, but we should find out soon. So stay tuned for the next iteration of building a Steam-based, extremely simple game from scratch using Codex. Until then, bye-bye.